Hello everyone, welcome to my channel CISE Topper Classes. Today we are going to discuss Chapter 15 Circle Exercise 15.1 question number 15 to 20 of M.L.aggarwal Class 9 Mathematics. So let us start solving this exercise here in this video. If you like this video, please like, share and subscribe my channel. Now let us solve here 15 question. The line joining midpoints of two chords of a circle passes through its center. Then prove that the chords are parallel. To prove that the chords are parallel, firstly we have given pointers M and L are the midpoints and O is the center. O lies in the path of ML on joining ML. O lies in the line ML here. Hence, OL is perpendicular here. OL bisects the chord AB. Hence, OL is perpendicular. Hence, so as OL bisects AB, OL is perpendicular here, and now we have by theorem, and as OM bisects CD here, it is bisects CD, then OM is perpendicular here. From that only we can say that angle ALM, angle ALM is equal to angle LMD, as they are alternate angles. From that only we can conclude that AB is parallel to CD, because if there are alternate angles then the lines are parallel. Hence AB is parallel to CD, and this is only we have to prove, hence proved from here. So this is the final solution of the question 15 here. Let us solve here 16 question. If a diameter of a circle is perpendicular to one of two parallel chords of the circle, then prove that it is perpendicular to the other and bisects it. So firstly it is given to us that this is PQ is perpendicular to AB and AB is parallel to CD. From that only we can say that if AB is parallel to CD and PQ is perpendicular to AB, hence angle OLD, because PQ bisects here perpendicularly AB, means O here angle OLD is equal to 90 degree, which is equal to angle OAMO, because of alternate angles as AB and CD are parallel, and hence proved that OL is perpendicular to CD, or we can say here PQ is perpendicular to CD, and this is only we have to prove in this question. Hence proved from here, and this is the solution of the question 16. Now let us solve here 17 question. In an equilateral triangle, prove that centroid and the circumcenter of the triangle coincide. So firstly here we will draw an equilateral triangle. So this will be like ABC. Here we have the point here O as the intersection of all the perpendicular bisectors. So let this the bisector of BC here we can draw like this, and the bisector of AB like this, and the bisector of AC like this. Let these points here as F, E, G, and here we will join OA, OB and OC from O, because this is a center. Here the circumcenter is the intersection of all the perpendicular bisectors, and from there only we will join AO, OB, OC here, and these are the perpendicular bisectors. So from that only we can say that his AG, O lies here on the um, on the line of these all the perpendicular bisectors. So here O is the circumcenter. From here only we can say O is the circumcenter, and as we join OA, OB, here this OB and OC, we can simply say that this AG is the perpendicular bisector also, and it divides the triangle here in median. So from that only we can say, in triangle we will take the triangle ABG and triangle AGC. From here we have AG as common, and AB is equal to AC because it is an equilateral triangle, and here BG is equal to GC because the median here divides it into two equal parts. So BG is equal to GC from here, because here this is the perpendicular bisector. OG is the perpendicular bisector here. So from that only we can say BG is equal to GC. And now we have triangle ABG as congruent to triangle AGC by SSS rule of congruency, and from that CPCT we can prove that angle AGB is equal to angle AGC. And as this BC is a straight line, so we can simply write AGB plus angle AGC is equal to 180 degree, and we will put the value here. So as AGB is also 90 degree and AGC is also 90 degree, so from that we can write it as angle AGB is equal to angle AGC, that is equal to 90 degree. And as we have proved that this line AG is perpendicular also and bisector also, and the O is the intersection of all these three perpendiculars, so we can simply say that O is the here centroid. From that only we can prove that this centroid and the circumcenter of the triangle coincide. Hence, centroid and circumcenter of the triangle coincide. And this is only we have to prove in this question, hence proved from here. As here AG is perpendicular and which is passing through O. Let us solve it in first part. In the figure given below, OD is perpendicular to the chord AB of a circle whose center is O. If BC is diameter, then show that CA is equal to 2OD. For proving this, we have here given that OD is perpendicular here on AB, means by theorem we can say that D is the midpoint of AB, of chord AB here by the theorem. And as D is the midpoint here and BC, O is the midpoint of the diameter BC. So here O is the midpoint of diameter BC. So we can simply write here as, because by theorem in a triangle here, if we join A and join AC, on joining AC here, we can simply get that this DO, because D and O are both midpoints of a triangle, and by theorem which we studied in a triangle chapter, we have, if the triangle has two midpoints, and then the base here is equal to half of that, means AC here, half of AC is equal to OD if D and O are the midpoints. From that only, and DO are parallel to AC. So here this AC, DO is equal to half of AC, and from that only we have 2DO is equal to AC. Hence proof from here, and this is only we have to prove in this question. The theorem of midpoint theorem we have studied in the chapter only. So hence proved from here. Now let us solve here 18 second part. In the figure second given below, O is the center of a circle if AB and AC are chords of a circle such that AB is equal to AC, OP is perpendicular to AB and OQ is perpendicular to AC. Then prove that PB here is equal to QC. Here as we know that it is given that OP is perpendicular to AB and OQ is perpendicular to AC. Means if this is perpendicular here, then Cn is equal to An, and from that only we can write that Cn is equal to 1 by 2 of AC and MB is equal to, again by the similarly we can say here also, similarly MB is equal to half of AB here, because here we have it by theorem only, theorem 1. Now this is half of AB, from that we can write Cn is equal to MB here, and as we know that OP is the radius of this circle only and OQ is also the radius of the same circle. So from that there only we can write that OQ is equal to OP, and as we know that if two chords of a circle are equal, then the distance from the center is also equal. So we can simply write by theorem 2 as we have studied. So this is NO is equal to MO from there only. By this also we can write it as, and Cn is equal to MB here. So using first and second, we can prove in triangle in triangle here MBP and triangle NQC. Here we have this, as we have proved previously, that Cn is equal to MB here and ON. If ON is equal to MO, OM means from the this third and second equation we can prove that OQ minus ON is equal to QN, means QN is equal to, and OP minus OM is equal to MP. So this is the first thing and this is the second thing here. Now from that only we can write angle CNQ. Angle CNQ is equal to angle BMP, as these each are of 90 degree, because this is a straight line and here this ON is perpendicular and OM is also perpendicular, so we can write this as, and now from these three points we can prove triangle MBP is congruent to triangle NQC by side NQC here by side angle side rule of congruency, and from there only CPCT we can prove that QC is equal to PB. So this is we have proved by CPCT. So this is the final thing and hence proved from here. Now let us solve here 19 first part. In the figure given below, a line L intersects two concentric circles at points A, B, C and D. Then prove that AB is equal to CD here. As we know that this is a chord here, and if we draw a perpendicular and let it this point as M, and this is a perpendicular, and in a circle, if in a chord a line is perpendicular from the center, we can write it as it bisects here. Hence BM is equal to MC from here. Let it the first equation, and again this OM is perpendicular on AD also, means AM is equal to MD here. Let it the second equation, and from first and second, on subtracting here, on subtracting, AM minus BM is equal to AB here, and MD minus MC is equal to CD here. And this is only we have to prove in this question, hence proved from here. So this is the solution of the question 19 first part, AB is equal to CD. Now let us solve here 9 second part. In the figure second given below, chords AB and CD of a circle with center O intersect at E. If OE bisects angle AED, means it is given to us if OE bisects. From here we will firstly, to prove this, we will draw here MOM, which is perpendicular to here AB, and ON, which is perpendicular to CD. And as it is given that OE bisects angle AED, from that we can simply write here that firstly we will write from here OM perpendicular to AB, means this is here perpendicular and it is the median here. So we can simply write that AM is equal to MB here, and DN is equal to NC. And if this is perpendicular, we can write here angle M is equal to angle N. This is given to us. And now we have OE as common in this triangle. So this is common. We are taking the triangle here in triangle MOE. and triangle here NOE. And as we know that OE bisects angle AED, from there we have OEM is equal to angle OEN. So this is the bisector here. Hence we have angle this as equal because OE is the bisector. And from that only we can prove that triangle MOE is congruent to triangle NOE by angle side rule of congruency. And as we have proved here this, we can simply prove that AB is equal to CD, as if we have OM is equal to ON by CPCT, and as we know by the theorem first that theorem second, sorry, if the chord's length, chord's distance from the center of the circle is equal, then we have this chords as also equal. So here we can say that AB is equal to CD by theorem which we have studied previously, theorem 2. So this is the final thing which we have to prove, hence proved from here. Let us solve here 21st part. In the figure given below, AD is the diameter of a circle with center O. If AB is parallel to CD, then prove that AB is equal to CD. Firstly, here we will draw OM perpendicular to OB and ON perpendicular to CD. As we have drawn here, we can simply see here that in triangle OAM and triangle ODN, we have angle AOM is equal to angle DON. So this is the first part here. Now from that only we can see here, if angle OAM is equal to DON, then this is also equal because these are the perpendiculars. From that we have this is angle DNO is equal to angle OMA, each is of 90 degree here, and this OA is equal to OD because this is the radius here, radius of the circle. From that only we can prove triangle OAM is congruent to triangle ODN by angle side rule of congruency. So here this is angle side rule of congruency. And now we can prove in this triangle as OM is equal to ON by CPCT. And if it is CPCT here, we can simply say here that OM is equal to ON, means by theorem, if from the center the perpendicular distance is equal, means the distance of the chords is also equal. So AB is equal to CD here, hence proved from here, and this is only we have to prove. This I have proved from the theorem which we have studied in the introduction part of the video. So you can go there to see this, hence proved from here. Now let us solve here 22nd part. In the figure given below, AB and CD are equal chords of a circle with center O. If AB and CD meet at E outside the circle, then prove that AE is equal to CE here. For proving this, firstly we will join here OE and draw a perpendicular M and N. M and N here. As we have drawn it, we can simply say that angle ONE is equal to angle OME, which is equal to 90 degree here, and OE is common here in the right triangle, hence it is equal. And as we know, here it is given that AB and CD are equal chords, and by theorem, equal chords are equidistant from the center of the circle, means OM is equal to ON here because equal chords are equidistant from the center of the circle. So here we can write this part, and from that only we can write triangle ONE is congruent to triangle OME. So this is by side angle side rule of congruency. Here we have or we have side angle rule of congruency. We have proved this, and from there only we can write here ME is equal to NE by CPCT here. And as we know that if a perpendicular is drawn on a chord, then it bisects the chord. Means here AM is equal to MB and CN is equal to ND. And as these chords, both chords AB and CD are equal, from that we can say that MB is equal to ND here. Put it as the second equation and first equation. Now we will subtract first and second. Subtracting first and second here, we will get ME minus MB will be BE here, and NE minus ND. NE minus ND is equal to DE here. And this is only we have to prove in the second part of this question. BE is equal to DE. Hence proved from here. So this is the solution of the second part here. Hence proof. Now the second part we can prove as, because AB and CD are equal, this is given in the question only to us that AB and CD are equal. So we will simply write here AB is equal to CD, and as we have written BE is equal to DE. So BE is equal to DE. From that only, on adding first and second here, on adding first and second, we can prove the second part of this question which is asked here. So this is equal to AB plus BE is equal to AE, and CD plus DE is equal to CE. And this is the solution of the first part, hence proved from here. Now this is the solution of last part of this exercise here in this question we have proved. Thank you for watching my video. If you like this video, please like, share and subscribe my channel.